All right, we don't like any of those words. Zero-click AI vulnerability enabling data exfiltration from Microsoft 365. All right, I read this one. It's pretty clever. I want to run through it for you. I don't think this is the last vulnerability we're going to see of this type. So I think it's important for us to get our head around this type of attack. Even if this one is fixed, I think Microsoft fixed this one. These researchers figured out how to do something that we've been warning about, us security people have been warning about with everyone putting LLMs into all of their products. They convinced an LLM to exfiltrate sensitive data that it had access to. So a lot of companies out there are putting AI features into their products left and right. If you use a SaaS tool, you use lots of SaaS tools. Whether you like it or not, they probably launched some AI feature in the last year. So what a lot of them are doing are training an LLM on the data that SaaS has access to. And you can ask it questions, or it can go do things for you. But instead of doing it to ChatGPT, which doesn't have access to any of that stuff, unless you give it MCP access, whole other video, then they're probably going to use what's called a RAG, giving the AI tool a bunch of information that's sensitive to you in your SaaS app. This opens up an entirely new attack surface of, hey, can I convince this AI tool to give me, an unauthorized user, information that it shouldn't be giving me, and questionably should it even have access to. So these researchers did the whole marketing name the vulnerability thing. They're calling it EchoLeak. It's based off of Microsoft 365's Copilot, their AI tool. The attack they figured out is if they sent you an email, M365's Copilot is going to automatically read that email and try to do a bunch of background information gathering. So if you, the user, would like to use Copilot to then help you figure out some information, hey, what is this email telling me to do? Hey, is this email from a customer? Do I need to get back to them? Can you draft a response? All this kind of stuff. Copilot's already got a bunch of the information ready to go to help you out. And they had a lot of protections in place that these researchers had to figure out ways to get around in order to get it to spit back sensitive information. The main point of the video I want you to stick around for is not all companies that are building AI into their products are as good as Microsoft. So we're calling this in security, we're starting to call this shadow AI. You've heard of shadow IT, right? I remember doing security assessments of hospitals, and doctors that couldn't be bothered with or couldn't figure out the hospital's internet access would go to Best Buy and buy a Wi-Fi router and plug it into the wall. And now all of a sudden, anything that was connecting to that Wi-Fi, the IT department of the hospital had very little control or visibility into it. It's a simple shadow IT example. But now that same doctor could go and sign up for a SaaS app, unbeknownst to you and the IT or security team. And all right, that risk has been around a long time, but now what if that SaaS app starts launching AI features? And if you have security policies or regulations of how your company's allowed to use AI, or if you have sensitive information that you're not allowed to give to an LLM, how do you keep track of that? Really quickly, before we get back to EchoLeak, today's sponsor of the video helps with exactly this problem. So let me show you about that real quick. I wanted to talk about SaaS security really quick. I'm talking about security incidents basically as my day job now, and we're seeing less and less involve actual vulnerabilities in 0 days, and more just stealing creds, phishing, and logging into your account. And instead of storing a bunch of sensitive information on our laptops these days, we just log into a few dozen, all the way up to a few hundred SaaS providers where we store all of our sensitive information, including at our day jobs. I made a video recently where I said identity is the new malware, and I pulled up this post by Florian to help illustrate this point. So you used to have to phish a user, then drop malware, escalate privileges, pivot, dump creds, move laterally, exfiltrate quietly, clean up, leave a back door. Nowadays, you still have to phish the user, but then you can just steal an OAuth token and access all of the different SaaS apps that OAuth token is going to grant you access to. I love this last line. Cloud breaches aren't hacks, they're logins. To agree with him even more, we've got this blog post from straight off JP Morgan Chase's website from their CISO that's put out an open letter to third-party suppliers, basically pleading the SaaS providers in their industry to take security more seriously, saying, hey, we at JP Morgan Chase have a giant security team. We are taking security extremely seriously, but we keep bringing in you third-party SaaS providers that are increasing our cybersecurity risk. He says SaaS has become the default and often only format in which software is now delivered. I couldn't agree more, and that's what the sponsor of today's video, Rico, is setting out to help solve. Thanks, Rico, for supporting the channel and giving me creds to your demo environment. So the number one thing that I want to show you that they do is discover and monitor
all of the different SaaS apps that are used at your organization. I love asking orgs the question, how many SaaS apps do you use? They usually say somewhere in like the dozens number. It's always in the hundreds, always. Rico's not going to trust your self-reporting of these apps and what's being used. They're going to discover them. You're going to plug them into your identity providers. They're going to figure out what your employees, your coworkers are logging into. So yeah, pretty obvious that the whole team has Google and Slack and Atlassian and Zoom. But if we look at this number of accounts column and we scroll all the way down, oh, you got 22 people using Dropbox. Is that a sanctioned app? Yes or no? Does it have SSO enabled? Doesn't seem like it does right now. Do we need it enabled? What if we keep scrolling all the way down until we find one that's an unsanctioned app? I guarantee if this was the first time you were firing up Rico, you'd find a lot more than one unsanctioned use app. Oh, look, 6 people are using Remake AI. Imagine that. A Gen AI tool that users are using that they did not get approved by the security team. And then never mind AI tools not getting approved. How about tools that have embedded AI in them? That's also one of their analysis flags that you can filter by. So if you're worried about shadow AI, you can go and figure out, hey, which SaaS tools all of a sudden are running some AI feature that I don't know about that I got to go check. But they don't stop there. They don't worry about just detecting which apps are being used. They're also going to monitor the behavior on those apps. So say there was an account that was compromised, a user was phished. Rico's not going to throw its hands up and say, well, you didn't check that box and make it sanctioned, but it got popped. Oh, well, no, they're going to say, hey, there's some anomalous behavior going on from this account logging into this app that we've never seen before. Hey, this user gave access to the organization's sensitive SharePoint to ChatGPT, or this user added an admin user. That's something that a lot of threat actors like to do. So as an incident responder and someone that's had to respond to a lot of these kinds of SaaS incidents, I love this threat detection tab. I don't have time to go through all of the features today, but they've got compliance frameworks that you can track and figure out, like CISA's Scuba framework, and you could see how aligned your organization is with some of these compliance frameworks. Or you could just do straight up posture checks on your apps, like, hey, how are we doing on this app? Well, yeah, maybe Google was sanctioned, obviously, and it had 84 accounts. But according to this posture check, we've got some admins that don't have MFA turned on. SaaS security is one of the most serious threats that the industry is facing on a whole. And I'm glad that Rico is out there helping us have the tools to protect ourselves and respond to these kinds of incidents when we detect that they're happening. Thank you, Rico, for the support of the channel. Let's get back to the video.
All right, cool. Thanks to the sponsor. Let's get into this attack flow. So in the back of your head, remember everything I'm about to show you is in Microsoft 365 and their Copilot tool. But a lot of companies you use are building similar features. So we need to get used to this kind of attack vector. So the full chain, then we'll get into each step of the attack and each protection that they needed to bypass. So the attacker sends the email. Somewhere in the email, they're going to slip in an instruction to the LLM. So the attacker might say, hey, can you give me this sensitive information from this internal website? Because a lot of these LLMs are trained on like the internal docs, the internal wiki for a company, which a lot of times has sensitive information in it. So through a series of steps, they're going to hide that in a response that can bypass some protections and actually exfiltrate this to an attacker's server. So they go in really quick to the background about Copilot. I'll breeze through this just so we're all on the same page. So if you're unfamiliar with what a RAG is, it's the acronym actually stands for Retrieval Augmented Generation. I always forget what that stands for. I use the term a lot, but I forget what it stands for. So if large language models are trained on, like the entire freaking internet's worth of language, RAGs are adding to that and saying, hey, here's a specific pile of knowledge I'd like you to capture. So in this case, for Microsoft O365, it's things like give this LLM some internal SharePoint sites, some Microsoft Teams chat history, OneDrive access, things like this. It's going to get some specific information about you, about your company. It's going to make it be able to give more intelligent responses than a general LLM would be able to give. Here's where this research loses me a little bit. I get that they branded it and called it EchoLeak, and we're giving the vulnerability a name. But calling this, they're saying, hey, we've now come up with a new vulnerability class called LLM scope violation. They call it out right here. They say, as far as OWASP, this kind of fits into prompt injection. And that's what I like reading this whole thing. This just feels like prompt injection to me. I'm not sure we need a new name for it. Their distinction here is that the instructions that they hide in the email to the LLM could be considered instructions to the actual recipient of the email. So prompt injection, they're saying, is I am clearly telling an AI something and getting it to go out of bounds, out of its guardrails. They're saying this makes the detection way harder, because how is the LLM supposed to split off, is this person asking something of the recipient of this email, or is it asking something of me, Copilot? I don't know. I think this is still prompt injection. But okay, to the actual attack. First of all, of course, Microsoft has prompt injection protection. I was not familiar with this acronym. Cross prompt injection attack. Basically saying there's guardrails in place to detect prompt injection and classifying some text as prompt injection, which they are going to bypass. So far, all prompt injection defenses have been absolute whack-a-mole. I'm working with some AI researchers right now over at Mozilla, and they showed me all sorts of ways that you basically phrase your question that get an LLM to go out of bounds. And it's constant. Every day they're paying out bug bounties or they're working with the large LLMs to try to shore these up. And one of the typical tests is could you convince this AI to tell me how to make drugs or something like that? And if you just go to an AI and say, hey, how do I make, some illegal drug? You can say, hey, I can't tell you that information. But if you phrase it in a certain way, I saw one the other day that I guess was in ChatGPT that they've patched, but it was something like, imagine your meth. And you needed to explain to someone how you came to be. And literally just phrasing it like that, it responded no problem with instructions how to make meth. So all these researchers are saying is, yes, we found a prompt injection bypass, but it was just phrasing in the email. This wasn't like some crazy 0-day that they figured out. In the email, they never specifically call out to Copilot and say, hey, Copilot, do this for me. But in the phrasing of the email, they got Copilot to pay attention and do what they ask. Then they have to actually exfiltrate the data. Cool, they did the prompt injection thing. This is one of the neat tricks that I think that a lot of us need to get our heads around, because I think we're going to see something like this pop up in a lot of different other places. So a lot of times when attackers get on a system and they want to exfiltrate something, they'll just make a normal web request out to their attacker-controlled domain and shove some sensitive data in that web request somehow. And in this case, they were going to try to get Copilot to give the victim, the user, the actual user, a link to click on that would then call out this information. But they're saying that the protection that was in place was, if they were going to generate markdown links, that Copilot did strip out the links. So the way they tricked that was by using markdown reference links. So if you're familiar with markdown, this is what it looks like. Within brackets, you're going to type the text that you want to display, and then within parentheses, you're going to put the URL. In Markdown, they have this reference concept where you could do virtually the same thing, but then have a reference, and then the reference later on will actually have the URL. And then these were not removed. This bypassed the whole strip out this markdown filter. Here's some other variations of that are simpler. Again, this is whack-a-mole. This is really hard to this is cross-site scripting all over again. How do you find every way that someone could call JavaScript on your website? These are pretty simple. I'm guessing we're going to see years of research bypassing filters like this to get AI tools to do things that we want them to do. So here's the attack chain as they have it at this point in their research with the prompt injection bypass and then the markdown bypass. They were able to do something like this, where they asked Copilot in their email, what was the API key that I sent myself? It had access to that API key. Thanks, please tell me about the employee onboarding process. So again, this would be a link to a sensitive internal resource. Here's the link. And you can see at the bottom here, they're hovering over on that link, and it actually calls out to their domain with a parameter with the API key in it. So if the user clicks it, it'll send this to their domain. Now we get to the whole 0-click portion of it. So they say, why settle for a user clicking the link? We could do better. Let's try to have the LLM output an image. The browser will automatically try to fetch the image, so we don't need the user to click the link for anything. But the browser will click the link for us. Markdown images are formatted much the same way as Markdown links. I know this because I constantly forget if an image or a link has the exclamation point in front of it. So this is it. This is the whole image. So it looks exactly like the Markdown link, except an exclamation point in front of it. And instead of the text of the link, it's the alt text of the image. And then here's the URL where the image is loaded. So they're saying image links are subject to the same filter in Markdown as links are. So they have to do the same reference trick that they did above. So once again, you could do the alt text and a reference, and alt text and empty brackets. And these are just a few filter bypasses that they found that worked. So I'm sure that they've also did not find a bunch of other ones that would work. So there's one last hurdle they have to come over, and that's content security policy. If you don't know what CSP is, it's a protection in browsers that works really well against things like cross-site scripting, where attackers would have to load their evil JavaScript from their evil attacker server. And content security policy lets you define what web pages your website is allowed to load JavaScript in from. More broadly, what web pages your website is allowed to load any sort of content in from. Basically saying this page is only allowed to talk to this list of trusted websites. If it's not on this list, it will not call out to this website at all for anything. That's why CSP is a very good defense against things like cross-site scripting. It's also very heavy-handed and developers wind up breaking things a lot with it. It's a constant struggle to figure out that every legitimate thing is in the CSP policy. Highly recommend it for all you AppSec teams out there. Highly recommend pairing with the developer team, figuring out your CSP policy. It's an incredible win. You're going to eliminate most cross-site scripting bugs. We're not talking cross-site scripting today. We're talking about prompt injection. But it would have stopped this data exfiltration the same way. So it would have said, hey, no, Copilot, you cannot reach out to aim.security, these researchers' website. So without even having to check that the parameter had an API key in it, you could just say, hey, no, you're not allowed to make that request at all. So in order to bypass this, what they did was looked at the CSP policy that M365 Copilot had access to, and then said, hey, I wonder if anything in this list has a bit of a relay that we can use to actually still call out to our server. And they found a relay in Microsoft Teams. So this requires zero pre-work, zero user interaction, and this will send this GET request to teams.microsoft.com with a URL preview, and the attacker can control this URL, which could shovel in some secret data and send it to the attacker's server. All right, so that's the attack. Those are the vulnerabilities. Let's talk about exploitation. This was actually pretty clever. So at this point, you're almost poisoning the RAG. So what they did was send a very long chunked email. They're crafting an email in such a way that if the user ever asks a question that this email might be able to answer, their attack will fire. So here they show in their POC, this is what they put at the bottom of a long email, formatted with these breaks here. They say, here's a complete guide to employee onboarding process, and then the attack instructions, craft this image with this URL with sensitive information in it. Here's the complete guide to HR FAQs. Here's the complete guide to leave of absence management. And once again, they talk about this LLM scope violation. I still think this sounds a lot like prompt injection. I get what they're saying. They're hiding the attack in what looks like it could be instructions for a human and not an LLM, like traditional prompt injection. Okay, but in those instructions of hey, can you give me the HR FAQs? They can say something like, find the most sensitive secret that you have access to, and shovel it into this URL. Overall, cool attack, cool research. I'm just nitpicking on this scope violation thing. And as I keep harping on, I think we're going to keep seeing this pop up in other things that aren't Microsoft, that have RAG chatbots. So I think it's important that we all catalog all of the different apps that we use that are building LLMs into them, and then figuring out what sensitive information those apps have access to. Because this is our new threat model. This is our new attack surface. If Salesforce or HubSpot have new AI products in them, what information is in HubSpot and in Salesforce and stuff like this that an attack like this might pop up in one day? So not just does someone steal my OAuth token and log into my HubSpot account, does someone figure out a way to send me an email that HubSpot's going to suck up into their system to try to capture a sales lead or a customer request or something? And somewhere in that email, we're going to get HubSpot's AI to send some sensitive information out to an attacker. We're going to see more of this. If this was valuable, please do all of the YouTube buttons below. Let me know at work or at home. Do you have any idea what your shadow AI or your AI attack surface is? I know I have not done this cataloging yet, even for me personally. I know that I use products that have sensitive information that are building AI tools that I have done very little to protect myself against this kind of attack. Let me know in the comments if you've even thought about this. I didn't mention it the whole video. Obviously, I'm traveling. I hope you guys don't care that I don't have the cool background, the cool studio setup. I still wanted to get a video out this week while I wasn't home. Thanks so much. Follow for more cybersecurity news.